This is Sesame. Sesame is a robot that can walk around, take naps, and he can also do whatever this is. What makes Sesame so special is that he's really simple. He's also really cheap. Okay, you're not cheap, you're, affordable. But seriously, you could build this whole robot for $50 to $60. All of the exact parts listed in the description, but for now, let's take a step back and take a look at how Sesame actually came to be. It all started a little over 4 months ago, when I was doom-scrolling robot videos, and I stumbled upon a video of this robot. It was this adorable little creature that this guy on Bilibili had made, and watching it, I thought it would be a super fun project to try out. Unfortunately, all the files for this guy's robot were locked to only Chinese accounts. Since I obviously wasn't going to fly over there for a weekend, I figured I might as well design my own version from scratch. Now, I wasn't going in blind. This wouldn't be my first walking robot I've ever built. Just about a year before starting this project, I built Red Hex, a dynamic walking six-legged hexapod that was a massive undertaking, both expensive and time-consuming. Building that robot took way too long and was super expensive, plus the documentation wasn't exactly easy to follow. So I set 3 main goals for this project. I wanted to keep the cost as low as possible. I wanted to make sure the robot was dynamic, expressive, and fun, and I also wanted to document the whole project and provide detailed information for anyone to build their own. With these goals, I took off designing. Oof, wow, that was pretty cool. Well, anyway, that brings us here. This is Sesame version 42, and here's how it works. Sesame's got 4 legs, 2 motors on each one. That means we've got 8 motors, allowing for a surprising amount of movement. And each Dude, can you hold the camera still? Each motor is mounted to these links here, and each link is marked with a number, so we can reference which is which later on. When I designed these links, I spent a lot of time trying to optimize them for 3D printing. That's why this part here is a square and this part here isn't. I'm basically optimizing the part so that it can be printed in one orientation without any support material. And that goes for many of the parts in this design, but some need supports just to get the features I'm looking for. These motors are connected to the internal frame, which holds everything together. And if we take a look underneath the internal frame, we can see where the battery's held. I actually had quite a few issues trying to figure out how to power this robot consistently and reliably. The original prototypes simply used a tether that powered it via USB-C power delivery, but I wanted to make it wireless. This current version uses a 3S lithium polymer battery inside the undercarriage. Although this battery does its job perfectly, it's not exactly easy to source this specific size. Also, batteries like this can get expensive pretty quick, so as I continue to improve the design, I'll definitely be looking into different ways to power Sesame, such as replaceable and rechargeable cells. The internals of Sesame are also pretty unique because we have to pack a lot into a small space. Let's take a closer look by taking the main body cover off. Inside you can see the main area for electronics. We've got a bit of space in here because we need to fit in all the extra wire from the motors. Mounted to the internal frame is either an ESP32 S2 Mini or the custom Sesame distro board. Basically, there's two versions of the electronics harness, one that's hand-wired and one that uses a custom PCB. And while we're on the topic, this PCB was provided by PCBWay, who was kind enough to actually sponsor this project. PCBWay is the go-to partner for high-quality PCB manufacturing and rapid prototyping. Whether you're a hobbyist or professional, PCBWay delivers fast turnaround, precision builds, and reliable service you can count on. I just received these boards, and genuinely, they're some of the nicest printed circuit boards I've ever handled. Their service was quick and easy to use, and seriously took this project to the next level. Thank you so much, PCBWay, for sponsoring this project. I made sure that my design could accommodate either the S2 Mini or the custom Sesame distro board on the internal frame. In another video, I'll go in depth on how I hand-wired the original version, but the distro board is definitely a better solution. On the front here, we can see that Sesame has an OLED display. We just use this to display faces, but technically it could display anything you wanted. I've gone ahead and made quite a few faces that come with the Sesame firmware, but making your own is pretty simple. I won't go into too much detail here, but essentially you can convert images to byte arrays and then paste them into the firmware. Speaking of firmware, Sesame is controlled with a Wi-Fi based controller that's pretty simple and easy to use. Once Sesame boots up, it creates its own access point which can be connected to by any device. Usually, I'll just use a phone. Once you're connected, you'll see a pretty simple HTML and CSS page that's actually written into the firmware. Pressing any of these buttons will send a signal over the robot, and it'll play an animation or start looping one of the motion commands. I've gone ahead and programmed in quite a few animations, poses, and movements, but I designed it to be simple to add even more. You see, all of these motors are coordinated with simple angle commands. You basically tell this motor to go to this angle, and it does it. That means making an animation is basically just making a sequence of angles you want the motors to go to. Man, wouldn't it be nice if there was a piece of software that made it really easy to make animation? Introducing Sesame Studio! It's written in Python and makes it really easy to make animation. All you have to do is set the angles and then make frames and stuff, and it totally works. Oh yeah! Once you have the angles, you can put them into the firmware. What? You don't know how the firmware works? Okay, I guess I'll explain. On the highest level, we're just sending motor commands, but how are we actually doing that? Well, the motors inside Sesame are something called servo motors. They can receive what's called a PWM signal that tells the motor which position to go to.
What do I see here? This is 3 different pulses. Each of these widths is 1.5 milliseconds. 1.5 milliseconds for a servo represents middle.
Unlike a DC motor, these motors have a sensor on the inside that tell it where it's located. Basically, all we have to do is figure out what PWM signal equates to what angle on the motor. Luckily, there are some handy libraries that do a lot of the work for us, but there are some interesting things to note with this firmware. First things first, we reserve the hardware timers 0 through 3 on the CPU core of the ESP chip. This step is basically like telling the processor to allocate processing to exactly what we need it to. Then we just map angles 0 through 180 to the microsecond position 732 and 2929. Now, something I ran into a lot during testing was that if we ran all of the servos at the exact same time, we would end up browning out the system, basically just drawing way too much power all at once. That's why written into the code is a 20 millisecond delay for every single motor movement. So that's how motor movements work, but then there's a whole tech stack that controls the communication and networking, display and graphics, and manages other inputs from the controller and command line. You getting all that, Sesame? Oh, wait, who's that? Sesame's friend here is based on all of the same principles of Sesame. That means Sesame's not just a robot, it's a foundation for making your own awesome version. This version here, for example, has wheels for feet and fancy motors sent over by the company Pettoy, meaning this guy is basically a mod of the original Sesame. Since everything's open source, including all of the original CAD files for Fusion 360, you could go in and change all of the links, make it go faster, make it move, different motors, anything. Okay, so maybe I got carried away designing different versions, but it's just to show that the whole thing's modular. So if you didn't really like the look of the face of the original, you could print out the version that covers these wires here. Or you could print out the version with cat ears. The possibilities are pretty open, especially because you can go in and edit the original files. I do want to note that I didn't make everything perfectly parametric, so you might run into a few errors trying to change stuff, but I've been very diligent about updating the GitHub with almost everything you could ever need for modifying or improving this robot. So yeah, that's Sesame. It took me about 4 months to design and build. Lots of prototyping and headaches, but it came out pretty good, I think. Like I said earlier, if you want to build your own, go for it, and I'll likely be posting some follow-up content, diving into a lot more of the technical details on things. Anyway, thanks so much for watching. Once again, thank you to PCBWay for sponsoring this project, and Pettoy for sending out some awesome motors. And also check out the GitHub link in the description, where there is a bunch of documentation, all of the files you need to make your own.